So picking up from where we were last week, we're going to look at observation systems, forecast systems, and how to use the Nav Canada flight planning portals. And this is for self-briefing. None of this obviates the ability to call up your flight information center and get a briefing on the fly as well. So a reminder when we discussed CRM last week that weather information is one of many pressures or factors that go into pilot decision making. Good information, whether it be weather or anything else, will improve that decision making, which should expand the safety margin of the operating envelope that we're working in. So I like to start with a little bit of philosophy. One of my old mountaineering guidebooks has got these little quotes from an old sage called O.L. Bear. And old Bear had something to say about searching for the information. One thing is that no matter where you look, you can't find what you want. When you think you found what you want, it isn't actually what you need. And what you think you need, you can't actually find. So it's a circular thing. And then the other thing is that, especially if you go down the Wikipedia rabbit hole, the more you study something, the more complex it seems to become. But I like to take my philosophy from rock and roll, and I think the Stones said it right. You can't always get what you want, but you can get what you need. So one of the things that you should have, any pilot that trained in the last 20 years or attended a rust remover probably has a copy of the local area weather manual. This was a great initiative led by Nav Canada 2001, I think it was. Good friend and colleague of mine, John Mullock, led the charge, and it's basically a weather manual for each of the GFA regions across the country. First half of the manual covers what we discussed last week and much more, basics in meteorology and aviation hazards, and then goes into the weather patterns of the individual GFA region, so British Columbia, seasonal weather, local effects, common problems along common VFR routes, like the routes from the coast to the interior, airport climatology, and it's actually free. So you just go to the Nav Canada site and download it, and I'll provide another link for that. And when you're viewing this later on, any of these URLs, nothing's active tonight, but you can basically just screenshot and grab that. Or if you like, I can write a summary and send it to Kim of some of these references. Okay, weather observation systems. We'll look at it from a global scale, just the type that goes into an analysis. We've got your basic surface weather stations. So you might remember a day where you actually talked to a human that went out and observed weather. Mostly that's been supplanted by some automation. So you've got the auto stations, and these are hourly and specials feeding into some data center. You've got upper air stations that launch balloons twice a day around the world and get vertical profiles of temperature, wind, and moisture. You got weather radars scanning large parts of the earth. You've got ocean fixed and floating buoys or drifting buoys. And then we used to have weather ships sitting on both coasts. Now we have ships of opportunity that are equipped with weather sensors, and they report on the northern routes across the Pacific, Indian Ocean, and Atlantic, and then aircraft in flight. And all this is automated now. The air reps, people might remember if they were flying in the Arctic or north of 60 back in the day, you had to report every 5 degrees of longitude with an AREP. Now all that is just part of AMDAR, so it's automatic. And then what's the main observation platform these days is any one of a number of satellites, which we'll talk about. So just a screen grab of a recent data analysis cycle out of one of the European forecast centers, and it just shows, this is a 6-hour agglomeration of surface observations, so land stations and sea stations. And you can see the preponderance of data in the Western countries, the developed countries, and the great areas of the world, either it's the southern oceans or the polar regions where there's virtually no data. And that's where the satellite really comes in to be able to fill in the blanks. You use ground truthing from land stations to calibrate satellite sensing so that they can get information where there otherwise would be none. So your typical auto station, you'll find these near the midfield and out of the jet wash area of most airports, a suite of sensors. There may in fact be a human that goes out to check some of the gauges, but for the most part it's automated. And in Canada, NAV Canada maintains about, I think, 230 aviation weather observation stations. There's obviously many more civilian and industrial sites. And then for those these METAR sites, so meteorological terminal aerodrome report and specie or special observation stations, there are 195 that receive terminal aerodrome forecasts or TAFs. So from that surface observation network and a little bit of upper air and other data, every 6 hours we generate a surface analysis. Recall from last week, we're looking for areas of lower pressure because that's where air is converging and air is rising. We're looking for frontal zones. So that's what you find on your surface analysis. And then upper air, these are twice a day. There's about 800 stations around the world. Canada's got 27 at the moment. Every 12 hours at 00 and 12 Greenwich, a balloon's launched with a little instrument package underneath. It goes up to about 100,000 feet before the balloon bursts. Takes about 100 minutes for that flight. The data is downloaded and sliced and diced in any number of ways. It's basically the backbone of numerical weather prediction. And one of the common products that you see come out of it is the constant pressure upper air charts, the 850, 700, 500 millibar, 250, and so on. There's 4 of these sites in British Columbia: Vernon, Prince George, Fort Nelson, Port Hardy. And then for people who live on the South Coast, you might be interested at the Quileute site on the outer Olympic Peninsula, or people down in the Castlegar, Cranbrook area might be looking at Spokane. If you're up north, we've got Whitehorse, Annette Island on the southern panhandle, and Yakutat on the northern panhandle. All of those stations, as I say, they flow into the data assimilation cycle, and one of the things we get out of this is the familiar 500 millibar, or roughly 18,000 feet above sea level chart. This is the one from this morning. Recall our discussion about long waves and short waves, and you see the long wave pattern out over the near the Bering Strait and southward, and then just approaching the coast, what we would call the short wave, just crossing Vancouver Island this morning. So long wave, short wave. Remember, the short wave has air mass lift ahead of it, and that's where the frontal wave probably will be, and it certainly was today. The dashed lines are either temperature or a proxy for temperature. We basically just say that the thickness of a layer from 1,000 millibar up to 500 millibars is equivalent to the average temperature through the layer, and we call that what those dashed lines are. So any place where you see one set of lines crossing another set of lines, that's an area of interest, that's an area of lift or descent, depending on whether it's ahead or behind the low. The other thing about contour charts or constant pressure charts is the flow is parallel to the lines. So in this case, over Haida Gwaii, the flow is from about the west-southwest at about 20 to 30 knots. Where the contours pinch together, that means higher wind speed, or if it's where the dash lines pinch together, that's a tighter thermal gradient or a front, if you will. And you see that down over southern BC where the isotherms are closer together. Chart that you would use more often for flying is based at around 10,000 feet, the 700 millibar chart. Exactly the same structure though as the 500. So we can see that shortwave trough not nearly as clearly as we could see it at 500 millibars, and that's because there's mountains in the way that disturb the flow, so you get a little more wiggle in the flow. And you can see the plot from the individual upper air stations, some temperature advection we call it, where it's moving warm or cold air. Okay, on to the big picture. I mentioned satellites. At last count, there's over 800 quote unquote environmental monitoring satellites floating up in the near heavens, but we're more interested mostly in the ones that are either geostationary or close polar orbit. So the geostationary, there are probably about a dozen or more that you could call meteorological, and then another dozen or so that are polar orbiting. We're mostly interested in this thing called Goes West, sits out off the coast of Colombia, and we'll show you some examples of that. Anytime you tune in the evening news, any app that you look at that's got satellite imagery on it, if you're in North America, you're basically just looking at a segment of GOES West imagery. So GOES, it's a nice short acronym for Geostationary Operational Environmental Satellite. Rocket science requires that if you want to have a satellite sit in the same apparent space in the sky, it has to be launched high enough up to match the Earth's orbit, and to do so you go up to about 36,000 kilometers above the equator, and that's where the satellite sits. It's got a huge suite of sensors, 16 separate spectral bands, plus all sorts of other gewgaws on it. Incidentally, GOES still operates as a SAR link as well. So when you hit your spot device, the GOES satellite is the relay. So the one of interest for us, it sits at 137 west. We get an image every 10 minutes from it. Severe weather forecasters down in the continental US can actually jack that up to an image every 30 seconds so they can watch like a tornadic storm developing in near real time. And the resolution at the equator is half a kilometer for a visible image and 2 kilometers for IR. Resolution degrades with roughly the cosine of the latitude. So at our latitudes, about half that resolution, but still pretty darn good. And a key point, NOAA owns these satellites. Canada, other than 2 synthetic aperture radar satellites, has no weather satellites of any type. So imagine that you're sitting at 36,000 kilometers over the equator, sitting on the GOES West satellite, and you've got a pair of glasses on that only allow 11 micrometer wavelength radiation to reach your eyes. And this is what you would see if you could do a little false color enhancement. This temperature range runs from plus 40 to minus 80. And what we're seeing is cold cloud tops in the intertropical convergence zone. Further north over the Pacific Northwest, some sort of clump of cloud over the Gulf of Alaska, some sort of a frontal system. Key thing is right over the equator, you can see things pretty well. Now look up at our neck of the woods. We're kind of on the edge of things, and yet if you take the data from that area, blow it up, turn it onto a polar stereographic grid, true at our latitudes, something that Steve talked about a few weeks ago when he talked about UTM. Then you get the same data, maybe a different color enhancement, but now you're looking at it without any distortion due to latitude. And the same temperature range from plus 40 to minus 80, but it's black and white. And this is the one that you get on the Nav Canada site. Incidentally, all this stuff is from about 3 o'clock this afternoon. The little white dots in the Nav Canada plots are the airports. So it's a nice handy geographical reference if you're not quite sure what you're looking at. So that same satellite, that same big view, you can cut out sectors elsewhere. So this is over the North Pacific, basically out to a little west of the date line. So you can see what's brewing, say, a week away. And this is really helpful in the wintertime because we can watch like a storm coming off of Siberia and winding up and hitting the coast. And it takes about 5 days or so from Siberia to here. And then my favorite, especially in the summertime, you take a couple of channels, you take the infrared and the visible, slap them together, and then put them over top of some type of land classification system, and then you get this false color image. Obviously, the false color is only available during the daytime because you can't get visible images at night, but incredible detail. You can see the thunderstorms over northeastern Washington, southeastern BC. You can see cellular cloud, basically a strata-Q over the Pacific. You can see a little jet streak coming into the southwest of Haida Gwaii. You can see shadow between higher cloud and lower cloud. Open water, even up at 70 north, you can discern things like the polar ice and all that. So incredible detail. Now, all this stuff, the main value comes when you animate it, and for the sake of bandwidth, I'm not animating anything tonight. I'll just try to be animated for you. Okay, so other than geostationary orbit, we have the polar orbiters, and as the name suggests, they go from pole to pole to pole, and they're much lower. They're between the space station and the geostationary orbit, around 840 as an average height above the Earth. And these pictures were taken from 10:54 this morning local time. Infrared on the left, visible on the right. Same dots that show the individual aerodromes. These are not available on the Nav Canada site, but are available on the Environment Canada main pages, which I'll refer you to. Okay, and so the GOES satellite does have a visible lightning detector, which covers all of North America pretty well, but we also, Canada is part of an international consortium of lightning detection. It's a relatively low-tech thing. You put some, you measure ground currents and triangulation, but Vaisala, the company that built this system, tells us that for the most of the populated part of Canada, we have resolution of between 500 and 1,000 meters horizontally for the placement of a lightning strike. You can see the amazing value that that would present for fire services around the world, and wildfire depends on this, and they actually have a lot of these sensors in the network. You can view this on the Environment Canada main pages, not again on the Nav Canada one, and you have an hour's worth of real-time data. Left-hand side is the national view, right-hand side is the regional Pacific view. This was from 22:20 or 3:20 local time this afternoon, showing that cluster of strikes over southeastern BC, another cluster moving off the Alberta elbow, and some stuff over western Great Slave Lake. All right, so completing the observational network, we have radar. Radar's got Canada has a pretty good radar network, although it doesn't cover all the country. It definitely covers our border zone with the excited states. And over BC, we actually have a little bit more coverage because of adjoining Alaska. So I think 29 sites across the country. Over the next year or two, these sites are being replaced, and so we're going to even better technology, which we won't get into, but quite exciting. If you go to the main Environment Canada web pages, there's a couple of tutorials on how to use radar and basically how to avoid things like thinking that a mountain is moving towards you. Looking closer into British Columbia, we have 3 operational sites: Silver Star, Prince George, Aldergrove, and then one that sits over just north of Grand Prairie and looks into the BC Peace. We did have an operational radar on southern Vancouver Island. It went snafu about 2 years ago. A new one will be installed, but probably not for several years. So the Silver Star radar, again, these images are from this afternoon during that thunderstorm outbreak over the south. It sits on the top of Silver Star Mountain right next to the resort gondola in the ski area. So that's about, as the crow flies, about 25 nautical miles to the northeast of Kelowna Airport. These range rings are 25 nautical miles. The Aldergrove one is situated about 5 miles to the west-southwest of Abbotsford, very near the border. So see anybody operating in a Boundary Bay, Pitt Meadows, Hope, got good coverage in there. And then southeastern Vancouver Island is reasonably well covered. This speckle that you see here, this is ground clutter, which is quite common with radar. The way you can get rid of that is, or to ignore it, is simply to animate a few images, and the things that don't move are most likely ground. Prince George, this radar sits on a hill about 25 miles to the southwest of the airport. And you can see this afternoon there was just some air mass instability happening there in the usual place over the Caribou Plateau, west of the Fraser, east of the Coast Range. And then Spirit River, about 35 nautical miles due east of Dawson Creek. Not much happening up that way today, but there was a good thunderstorm building down south of Slave Lake. Caution when you're using radar, especially if you're using it with satellite imagery. Satellite imagery, there's not too many holes, but there's lots of gaps, as you saw in that radar network map. And so just put one way, there's an old mathematical expression that absence of evidence is not evidence of absence. So in this case, if the radar signal doesn't show anything, it doesn't mean that there's nothing there. It's just that it may not be reached by the radar. Any radio wave, when you project it horizontally due to the refraction from the atmosphere, is going to go up the further away from the radar. So between attenuation, refraction, terrain blocking, and a few other factors, the further away you are from the radar, the less likely it is that you're going to see something like the rain shaft at the bottom of the cloud. And as I mentioned before, the other thing with radar is animate it, and that way you can detect targets. A reminder that on the Nav Canada self-briefing pages, that there's a link to all the webcams at the airports around the country. BC's got several dozen. We won't drill down to each one of them. The cool thing is that when you call up a METAR, you're going to, if there is a weather camera like at Kelowna or whatever, you're with the METAR, you're going to have a link to the real-time webcam. But there's lots of places that don't have METARs, like Oliver, Grand Forks, Merritt, and that's a way to access that. And then we'll look at some more less conventional observation sources. And I don't start the day without going to Drive BC. This is somewhere between first coffee and first phone call. And the webcams that are available on Drive BC are invaluable. Kim mentioned in last week when we did the search up at Rogers Pass that we were using some of the Drive BC information. Well, I was able to look at it and determine exactly when the weather went down, coincident with this the missing pilot's flight path. So we had pretty good evidence that it was weather that probably caused him to try to escape. And the only problem was in the actual search, it snowed more than a meter between when we saw that happen and when we were out there. So he was already buried. But from a flight planning perspective, consider the number of webcams that are positioned in a place that has a good view of surrounding terrain and highway passes, and you've got an invaluable aid for determining viability of VFR. And if there's no weather rocks around, or the fact that you can see water on the pavement, this is usually a pretty good indication that it's either raining or it has rained recently. Many of the sites do have a co-located weather station though, so you can take a look at that data, temperature, humidity, wind, and they also have a 24-hour recall on the webcam itself. So say you're going to the coast and you're not quite sure what the Hope for instance like, but you can call up Allison Pass and watch the 24-hour loop. So just a few examples from Drive BC of that. Remember, just below the old toll booth on the Coquihalla, heading down towards Hope, the Zopkius rest area, good view of Yak or Knack Peak and the head down into the Coquihalla Canyon. And you've got a weather station that goes with that. You've got a geographic reference underneath there that tells you where the camera is located and which way it's pointed. Highway 20 west of Williams Lake going over to Bella Coola, top of the big hill, nice clear view over to the Coast Mountains. Give you an indication of what you might be up against. A couple more interior routes, heading east from Vernon over to the Arrow Lakes. This is Monashee Pass on Highway 6. And then for those folks up north, Fort Nelson heading over to the Hot Springs or Watson Lake. Steamboat there is a high point on Highway 97, great view off to the west. This is all stuff that's freely available, and so don't limit yourself just to a METAR. You know, you've got a lot of other possibilities. And in addition to that, if there's a ski hill in your area, it's got a webcam. And mostly they're freely available. The only time maybe is in the winter when the PR doesn't match the snow report. But most times you can get a near real-time report. So this one is helpful. It's on top of Revelstoke Mountain Resort. It tells me the time. And from that same web page, you can also get the elevation, so you can get a sense. Revelstoke Airport is down a little and to the right of the balcony here. Combine that with the webcam from Revi that looks over towards the western passes, you'd have a pretty good idea of whether it's a viable route into the Columbia Valley there. Or say you're planning a local VFR flight out of Vernon, then you call up Silver Star webcam and maybe you revise your game plan. Or suppose you want to fly across the Rockies and you want to go up through Rogers Pass. Well, Parks Canada has got a webcam that They update every 15 minutes. It sits on Mount Fidelity at the western boundary of Glacier Park, looking straight on. This is Highway 1 running up to the Big Illecillewaet corner and Rogers Pass to the left. So pretty good indication of whether or not this would be a good day to fly. So anyway, what do we do with all that stuff? We've got surface data, ship data, upper air data, satellite data, all these auxiliary networks from highways and forestry and industry. Well, you got to do something with it. And back in the day, when it was the guy I was chatting with just before we went live, we did a lot of subjective hand analysis of all that. We plotted things on maps by hand, and then we drew lines around them, isobars and isotherms, and then we used some elementary physics and projected that out into time. Well, these days you take all of that data and imagine some type of a, if you will, some sort of a wire grid that either encapsulates the entire Earth or at least covers the area well beyond where you're interested. And imagine rather than a single layer of wire, you've got perhaps a layer of 20, 30, 50, 100 layers of wire mesh. They may be perfectly aligned with each other in the vertical, or they may be offset on the intersections of the wires. And then in the horizontal, between each set of wires, there's a certain spacing. So in Canada, the highest resolution operational model that we run is on a 2.5 kilometer horizontal grid, and that can give you forecasts out to 48 hours. And if you're not impressed by that, you should be, because that is an amazing accomplishment in today's world. The math and the physics is a little bit complicated, but basically you take all that observational data, you quality control it in some sort of a objective fashion, plug it onto this grid, plunge through all the math and physics, and out the other end comes a forecast, a raw set of numbers, which usually requires some sort of statistical processing to make it useful. So the role of the forecaster used to be a lot of analysis and then a little bit of projection. Now the forecaster is more near the end of the chain, and they're a translator or an interpreter. They take raw data and they convert it into more useful products. So if I, for instance, was creating the GFA, I would, on my screen, would receive some sort of gridded version of this sort of dog's breakfast of charts on the left, and I would use that as a starting point for drawing in areas of likely cloud cover, using my theory and everything else, and then I would put on the labels based on those upper air soundings and projections of how those upper air soundings would evolve with time. And so that's the GFA, not to diminish it, is actually a fairly simple example of the type of product that can be generated these days. But while we have it there, reminder that the GFA is just that. It's a general area forecast. Why do we not call it a GAF rather than a GFA? Well, it's because back in the day when it was a text product, in other words, a description of a picture, it was called an FA. Then it became a graphical one, so we call it a graphical FA. Layer cloud, and the definition of layers is that the separation is less than 2,000 feet in the vertical between them. So the bases of those layers and the tops of those layers, whether there's embedded convection in it, the general visibility and weather to be expected, and then remarks, which may be on the right-hand side, or in this case showing embedded thunderstorms and the like. Thing to remember about a GFA, everything in it is above sea level unless otherwise noted, and you'll know that it's not above sea level if you see the word SIGs, so for ceilings, and AGL for above ground level. So a METAR, a SPCE, a TAF, everything there is above station level, above ground level. Everything else is above sea level, all those constant pressure charts and upper winds and all that sort of stuff. Sometimes it can be confusing, but you could do a quick check. Say you were going over to Cranbrook, and so you see on this GFA, it shows 4,000 to 6,000 broken for the bases, You know that you're going to be flying in terrain that's 5,000 feet above sea level at minimum. Well, that's another way of saying that that terrain is obscured. All right, take a quick break here, Kim. I gotta have a little glass of water, and if there's any questions at all.
Yeah, there is a couple of comments in here. One of
Okay.
them from one of the pilots on Vancouver Island who
Yep.
hadn't seen the weather in BC before. So I'm glad you were here to pick that up and get the link and go ahead. There's a lot of reading in that. It's a really, really good resource for the crews. I'm just scrolling through so I don't miss anything significant here. Let me get down here a little bit. One question will be answered in the next section. Enjoy. So a question from Ashley. It's gone again. How large do these thunderstorms or cloud accumulations have to be to show up on the layered map currently on your screen? So that was about 15 minutes ago. I think that's a very difficult question to answer, Ashley, because I don't remember exactly which slide it refers to. So it's the temporal resolution, the dimensional resolution on one of those slides that you put up. How
Well,
big can it be?
let's go back to that satellite image. Here we go.
Possibly, yeah.
So, that's the one. Yeah.
Yeah, that's it.
So at
Yeah.
3:20 this afternoon, the image on the right-hand side, um, you're actually looking at individual thunderstorm cells. Keep in mind that the resolution here is about 2 kilometers horizontally. So for the most part, we're seeing the anvils, and we're looking at probably the length of that anvil is 50 or 60 miles. So, but then over the central interior, those individual thunderstorms that I was talking about, you can actually see the tops of them. You can imagine that, say, one of those little dots is about 2 or 3 kilometers horizontally. So you won't be able to see every queue. You won't even be able to see every towering queue, but typically they don't just form on their lonesome. They're surrounded by others. So the telltale sign for a thunderstorm is to look for that anvil,
Mm.
and basically you're going to have these, with time, they'll form into lines and they'll be moving, and that's the way you can tell. Off the coast, this open cell stratocumulus, I would say that those individual white blobs are on the order of 10 kilometers across. Um, and then this cirrus up over the northern Gulf and the shadow to the north of it, that's again a space of about 10, 15 kilometers in the horizontal. So not as good as a spy satellite, but still pretty darn good. Hope that answers
Perfect.
the question.
Yeah, so actually, if that doesn't answer the question, flick me an email. We'll talk about it offline. From Steve in Southwest, windy.com, I have the app. It's actually quite good. I use it quite a lot. So for those of you who want to investigate Windy, I have an Apple product, so I get off the App Store. We're bouncing around all over the place here.
No, that's actually a good. It's actually a good point there. I know that there are a lot of apps out there, and I guess I should have prefaced this with everything that I'm presenting tonight is either a label of NAV Canada, Environment Canada, and the two are synonymous because NAV Canada gets all of its weather data from the Meteorological Service of Canada, which is a division of Environment and Climate Change Canada. I know that there's lots of other, I'll call them wrappers. You should first of all look for does the content meet your needs, and don't get too dazzled by the shiny wrapper. A lot of the apps that claim to be, it's like I don't know, such and such a radio station or a TV station will say that they're their Doppler radar. It's not theirs. It's the National Weather Service or the Met Services, and all they just put their sponsor label on it. As far as I know, in Canada, there's only two cities, at least in the West, that own their own radar, and that's just for some hydrological modeling within their city limits. So don't be dazzled by that. All of those apps are good because the visualization side of it, NAV Canada and Environment Canada are way behind on the visualization stuff. I'll agree with you there. But if you just want something quick, and I'm talking mostly about the stuff that we're going to have at Access as we're preparing to launch for a mission. So I've got the luxury of time right now that I could go and get all sort, spend an entire day for a briefing, but I don't know, that's for a training flight, but for a real mission, we may only have a couple hours to get it all together. So,
Right. And Sean from Southwest has a question. Environment Canada's marine forecast includes a weather station at Squamish with wind speed and direction. Any idea why this isn't in the Nav Canada weather site?
I have no idea, but you should certainly ask Nav Canada why it isn't there.
Right.
Yeah, the most likely it's not a Nav Canada owned site. There should, like Vernon is an example of it. It's not, you don't get a METAR for it. You have to actually go to YVK and look at the city airport site in order to get their observation.
Right. The CCTV footage, yeah, from a search coordinator perspective, is extremely valuable information. For anybody who's read Transportation Safety Board of Canada reports into accidents, they often show the actual imagery from sites closest to the crash site, so they could actually reconstruct the historical weather. That's something that plays a big role in the Searchmaster course that the RCAF puts on. So the CCTV footage, to be able to link them all up on a screen and loop them on the same timeline so that they're showing exact information at multiple different directions, is extremely valuable information. So I won't delay this any further. I know you're going to launch into a little bit more, Ken, but there's no other major
Okay,
question.
no, yeah, no worries. And I guess one more comment I would make, no matter what data you're looking at from whatever source, always check the date and time on it.
Yeah,
Um, it's amazing how a METAR from yesterday can be construed to be a METAR from today. A chart could be 2 weeks old but have the same 12 Zulu on it. So look carefully at all that stuff. Okay, so I've talked about all the great stuff that's out there, and then how do you actually look at it? So the end of this presentation is basically just a quick discussion of what you've got for online resources in that regard. I think Nav Canada is in a bit of a transition right now between their legacy site and their new flight planning site. But these are the two portals that are active right now that allow for self-briefing. And a reminder, if you're not quite sure what you're looking at, it never hurts to actually call the FIC and get a briefing. That's what one of the things they get paid to do. So from the Environment Canada site or from Nav Canada, if you call up aviation weather, it brings you to the AWWS. I call that the legacy site because as of October of last year, it no longer hosts NOTAMs because of the ICAO format change. But from here, it does link to, the weather and NOTAM pages will link over to the CFPS, which is the new one. I like the legacy site because it's sort of logically oriented. You've got alphanumeric data versus pictorial data, and then it's got a nice clean link to south of the border and a few other things that you might need, like sunrise and sunset. But we'll go through it anyway. And then the new site is the Collaborative Flight Planning site, otherwise known as CFPS. So if we dive into the AWWS, this is just a screenshot, so I'm not going to be activating any one of the links. We've talked about most of the product, and I'll just scroll through. So you're faced with this menu, and at the very top there, there is an option if you've got like a canned flight plan, canned flight route, that you can subscribe to my weather data and get an email of a package of data. I tried that for a while and found that it was less than reliable. So for most Casero operations, route data, or local data will fit the bill quite well. Route data, you plug in the start and end point and any waypoints along the way, and then you define a corridor, usually 50 miles or something like that, and it'll come up with all the METARs and upper winds and things for that area. Local data, you just plug in something like YXS or CYXS, and it'll come up with data within whatever radius you ask for. Down within the alphanumeric data, what to ask for? Well, because there's no longer NOTAMs on the AWWS site, there's no sense answering weather with NOTAMs in the first question that pops up. Working from left to right on the alphanumeric, the AirMet and SIGMET. An AirMet is, let's say the GFA is not perfect and it's missing something which is significant. The AirMet basically amends the graphic area forecast, and it's a text message that comes out. It might say something like towering queue developing Southeast BC after 21Z. A SIGMET, that's a more severe version of that. This is a hazard, which is developing or is expected to develop before the next GFA can be issued. And it'll say something like, even though the GFA may say thunderstorms to 30,000 feet, the SIGMET may say line of thunderstorms tops 34,000 from Abbotsford to 30 east of Kamloops, moving northeast at X number of knots. And that'll be a text message as well. So you always want the AirMets and SIGMETs because they're basically the updates to the forecast. The upper winds, the FDs, these are gradually being replaced. This is a text product at the moment. You plug in your airport of interest and it comes up with the closest one for it for a certain elevation. There's a new product, a graphical one called an FB, which is not available on this page, but available on the other. METARs and TAFs, when you plug in either route data or local data, METARs and TAFs will come up as part of the package. NOTAMs, as you say, we can't get them. Volcanic ash, if there were airborne volcanic ash and you were flying in a turbine or jet aircraft, you would want to know about it because it does horrible things to those engines along with a lot of fancy electronics. But that'll be a glowing red symbol if there is an active volcanic ash eruption. Pilot reports, we don't see nearly enough of them, but make sure you ask for them in case there happens to be one. The live RVR is a bit of a misnomer because other than Abbotsford and Vancouver, there are no runway visual range reports attached to METARs, but basically it gives a snapshot of what's broadcast on the ATIS for the airport that you're interested in. And then the VFR route forecast, this is like a mini GFA, but in text form and only for two VFR corridors from the coast into the interior, daytime only, summer only, and it's the Hope Princeton and the Fraser Canyon. Flight conditions, that's I think Kim showed this last week, it's basically the green, yellow, or red for VFR, MVFR, or IFR conditions along the area of interest. SIG level, SIG mid-level, this is above 10,000 feet, so probably not of too much use for you. The upper air analysis, this is where you can get the constant pressure charts. You used to be able to get an 850 millibar or 5,000 feet above ground. It's no longer available on this site, but the 700 and 500 are. The graphical area forecast we talked about, and also the icing and turbulence part of that product. The weather cameras that we talked about. The next two charts are related to commercial high-level aircraft above 24,000 feet. The local graphic forecast we talked about, or no, we didn't talk about. This is a subset of the GFA, only up to 10,000 feet and in 3-hour segments and just for the coastal sections of British Columbia. Upper winds, this is a graphical version of the FDs, but it doesn't seem to be active on this site anymore. The next two are Atlantic high-level stuff. The radar imagery, the satellite imagery, definitely want that. Surface analysis for sure. Don't need the North Atlantic, and you don't need the upper level 24,000. Okay. So as I mentioned here, this is kind of the list of stuff, and if you want, I can package just this page as a separate file to Kim so that you can use it for your flight planning reference. If you're on the coast and you're looking to fly into the interior, you want to see that VFR route forecast, or vice versa. And if you're on the coast, you'll want the local GFA. Right, and then on the CFPS side, I will confess I don't know enough about it. I haven't been using it enough yet, but because it's got NOTAMs on it, I've been going that way. Similar entry, you select the weather and NOTAM tab. A little box pops up, you plug in your airport ident or starting point or navigation aid or whatever, click search, and then you can click or enter more points along the way if it's a route or something like that. And then you can define the route radius. Most but not all of the products that are on the AWWS site, you select them. Once you're done, you hit search. My experience has been less than satisfactory in terms of the order of the information. It definitely isn't in the same coherent order that the AWWS presents it. And there seems to be a lot of repetition of essentially satellite and radar data. And other thing to watch is that the default for METARs is only 1 hour, and typically my rule of thumb is that if you're going out for X hours, you need 2X hours worth of history. So you're going out for a 3-hour flight, you want 6 hours of history. Anyway, I wish you good luck on that. But from this same page, you can find the link to the local area weather manuals that I talked about. And yeah, so good stuff. Now, not being a pilot, I don't really know the logic behind the way NOTAMs are arrayed on the site, but it seems like you jump from something about a runway condition report to a no-fly zone over Iraq and back down to airport firefighting hours of operation to don't fly over Iran. So I think it'll get better with time, but my sense is that they're moving towards CFPS because that's also where you file your flight plan online. So I probably sped through this pretty quickly. I'm hoping that the pilots all know how to read an hourly, and if you don't know how to read any of the information that I talked about, this guide, the Aviation Weather Services Guide, is downloadable from the NAV Canada site, and it covers in great detail every product available through their portals. And as mentioned, the Weather of BC GFA handbook is pure gold, and you should have a copy of that. Definitely go to any of the flying clubs. I'm pretty sure would have one sitting on the shelf somewhere. I know that they're all handed out as part of basic flight training back in the early 2000s.
Yep.
All right, so I'll wrap this up with a plug for my former sponsor, and which used to be the Atmospheric Environment Service of Environment Canada, and is now the Meteorological Service of Canada of Environment and Climate Change Canada. But two pages, or one page that you should bookmark, and that's weather.gc.ca. It's got lots of information. And then we have an app. I can say we, it's the royal we. WeatherCam is, I used it today. I got severe thunderstorm alerts for my area in real time. Great stuff. So definitely get those. All right, over to you, Kim.
Okay, just a couple of questions that popped up. Bill, who wrote a very nice email that I forwarded to you a couple of
Right.
days ago.
And
Uh,
thank you for that, Bill.
yeah, thanks, Bill. And so the question that he's asked is, how accurate are the ASCP products except for a general indication?
So the ASCP is a totally automated product. It's available off the AWWS site. Let's just go back to that. Yeah, right on your screen is obscuring, but I think it's right in here is the ASIP toggle. Yeah, treat it as raw data. It's not massaged in any way, so I really can't say, can't give you a numerical number for it. Whether its accuracy, I don't even know if an evaluation has ever been done on it. But it's an experimental product. Commercial dispatchers would probably have a much better sense of how useful that is.
Okay. And John in Southwest is asking, do you need a login for CFPS?
No, you don't. That's a cool thing. You just once you go there, you just hit that weather and NOTAM page. I think you have to log in if you actually want to file the flight plan. But
Yeah. People talking about some apps. I have all of these apps. They're actually quite good. The Aero Weather app is quite a good app, but I could probably talk for about half an hour on the apps that are on my iPad and my iPhone. But so there's plenty of weather material out there. But what stands out for me is that, and I said this last week, in a major SAR case where we ramp everything up and start launching a lot of airplanes and everything gets super hectic, we often fly the next day where the weather system is equally bad, sometimes even worse, and it can hang around for days. Some of these systems are massive. That's what gets the pilot into trouble. So getting the best information possible is the objective. So pilots definitely know about navigation meteorology. Some people scrape through, they're not the greatest at MET. A lot of the search coordinators, they may be navigators, and so they may not have as deeper understanding of weather. So I notice in evaluations and SAR cases that they will defer to somebody who's a pilot, say, well, you got a license, you go ahead and brief. What I found in national SARXs is the Royal Canadian Air Force has a MET service. And so for all of the SAR pilots, these are all the professional captains and majors and so forth, the first officers, the navigators who all understand weather. They go to the meteorologist, the SME, and they do a mass briefing every morning or a 1 week SARX, and the MET guys give the full briefing as you would. And I think that's an invaluable service because we're flying in very tricky weather. There's a lot of mountainous terrain, there's mountain waves, there's updrafts, downdrafts, and turbulence, icing, the whole shebang. And it occurs to me, Ken, that we could probably do something like this on a major SAR case. Instead of asking a local pilot to do a bit of a weather briefing and then just rely on the pilots to do their own pre-flight and filing, to have an extensive weather briefing for the weather that we're going to fly in from somebody who is an SME. So, and I'd be kind of looking a little bit towards you. And the way the Canadian Met Service does it for the Air Force, the guy's probably in Ottawa or wherever he is, could be in Winnipeg, and he does something like this. He'll put up on the screen the GFA, he'll describe the weather and give all the relevant information. He'll ask for input. And these are to professional pilots. And I thought this was awesome. This is a standard operating procedure for the military. And we could do something very much the same because we have the resources that we can tap into. So it's something I'd like to talk to you about afterwards because some of our search coordinators are pilots and some are navigators, and the weather is critical for our operations. We don't want to send anybody out into an environment that's unsafe, and there's a ton of material out there, and you want an SME to interpret that data, give a forward-looking estimate of the weather. And that goes for evaluations too, because evaluations sometimes are done during an actual SAR case. The last two major SAR cases, evaluations were conducted at that time. And so we need to operate, we need to train the way we fight. So I'd like to talk to you a little bit more about it because you could do it remotely. But I want to thank you so much for your presentation tonight, part two. We're just past the top of the hour. I really appreciate the work you put into this. You've put in pretty close to 100 slides. You do what I do. You update your slides right up to the last minute if the data is
Mhm.
changing. And I
Yep.
really appreciate everything that you've done to come out here and to do all this training for us. So I'm just going to see if there's any more questions before we wrap it up.
Yeah, no worries. It's a pleasure to do it, and for those people that have longer memories, you might recall back when there used to be a good editorial page on the Vancouver Sun, and Len Norris was just did some wonderful weather gags over the years.